Alrighty. Yep. So let's start with a simple quadratic equation. Okay. So what makes this thing an equation? What makes this an equation in the first place? What makes this thing an equation? The equal sign, yeah. We're saying two things are equal, right? We're saying two things are equal. That's an equation. That's all it is, okay? What makes it a quadratic equation? What about this indicates this is quadratic? Because Mr. Whitmire said so? There's a clue.
Yes.
There's a clue. That's part of it, sure, right? You trust me, and I mean, I want you to trust me, but there's a clue here also if I didn't tell you this was quadratic. The x squared, exactly right. Okay, when you have a variable squared, all right, your variable squared there, and no higher power, that makes it a quadratic equation, right? So don't get freaked out by the word quadratic equation. That's all it is, just an equation, something with an equal sign, right? Where we have a quadratic as our highest power, 2 as our highest power. All right, the first method we're going to look at about how to solve something like this is by graphing. And if you have a graphing calculator handy, you might want to get that out. Okay, if you don't have a graphing calculator handy, no sweat. We'll sketch out a graph of this too. But if you have your graphing calculator, you can feel free to use that instead. So don't feel like you need to graph here with me. If you on your paper, you can just feel free to use your graphing calculator. And I'll do it on the graphing calculator too. Yeet. Okay, and the way we're going to solve, and by the way, this strategy works for any quadratic equation we come across. Any quadratic equation we come across. Okay. So here we go. We're going to graph f of x equals x squared. Okay, so we're going to graph the left-hand side of the equation. And then we're also going to graph, and I'll use a different function here, g of x equals 9. Okay, so I'm going to graph the left-hand side of the equation. I'm going to graph the right-hand side of the equation. All right, so let's go ahead and do that here. All right, so you have the graphing calculators, right? You know how to graph stuff. What do we press in order to graph stuff? Well, what do
Y equals.
Yeah, we first got to press the y equals, right? Clear anything out. All right. Also, make sure that none of these plots are highlighted. And what I mean is, okay, if you see something like this, okay, in one of your plots, you need to press the arrow key up here, okay, so it's highlighted and hit enter. That'll turn it off, okay, because you don't want to be graphing any plots right now. In y1, let's go ahead and put in x squared, so x squared.
And y2 is just 9.
And y2 is just 9, the other side, exactly right. This is a technique you can use to solve any equation you come across in this class. Any equation you come across in this class, you can use what I'm showing you right now. Graph the left-hand side, graph the right-hand side. Okay, there it is. And where will our solutions be located? There's y1, the x squared, right? There's y2, the y equals 9 graph. Where are the solutions going to be located? How can we use this graph to help us solve it? Tyler? Yeah, where they intersect, where this horizontal line intersects the parabola there. Now, of course, if you have a different equation, you might have a different looking graph, right? But it's going to be wherever the two graphs intersect. Now, you can kind of like eyeball it there and determine what the solutions are going to be, right? You kind of look at it and say, well, okay, they intersect about there. If I go, looks like it's about -3, and right here also, +3. Okay, you can kind of eyeball it, but there's a way to have your calculator do that work for you. You guys know what to press in order to get the calculator to do it for you? So we're going to use this a lot. Second trace. Okay, second button and then the trace takes you to the calc, C-A-L-C. See how it's in blue, and I press this blue second button to get there? The calculate menu. Okay, now can you tell me which command are we going to use to find the place where the two lines intersect?
5.
Yeah, exactly. Yeah, it's exactly right. It tells you what to do. Okay, then the calculator tells you how to get it. All right, so it's asking you for the first curve. If you notice here, my little target cursor there, it's on that first curve. I can see it's on x squared, so I can hit enter. And then it's asking what's the second curve. And again, I can see here, I'm on the second curve, so I hit enter to select that one. And then it didn't really move, but the question changed. It's now asking me to guess. Okay. So for the guess, you want to use your arrow keys and move close to one of the points of intersection. You can pick whichever one you want. I'm going to pick this one. Okay, I'm going to move it very close to that point of intersection. It's not exact, you can see, but we'll hit enter, and voila, -3, 9. So my solution, my x is -3. Okay. If I want to do the other point of intersection, I'm going to hit second trace again, do intersect again. Okay, enter for the first curve, enter for the second curve. But then for that guess, I got to move my cursor. You see it's still over here. I want to move it now over to this side, again, using my arrow key right here. Get very close, and then hit enter one more time, and then voila, it gives you the +3, 9. That's the point of intersection there. Okay. If you don't have a graphing calculator, please make sure to get a hold of one. You may not continue to bum Mr. Whitmire's calculator every single time. I will continue to warn you guys every single day of this unit, okay? Because I know there are those of you out there that are thinking, yeah, I won't get one. I'll just borrow Mr. Wids every day. It's gonna be fine. You know, he won't care. You know, everyone else will get one, but I won't get one. You need to get one, okay? So please do not be lazy about this. Get a graphing calculator. If money is an issue, write a letter. If you don't want to pay the $20, you need to write a letter saying that it's a financial burden. That's all you have to do. We can get you a free calculator, okay? But you got to write the letter. I can't just give you one, okay? So please, 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 all right? You know your financial situation, get the calculator, okay? I have a few more rental sheets if you need one. Okay, does anyone need a rental sheet? So all of you right now that don't have calculators in front of you, you have a rental sheet already, or you have a plan about how you're going to get a calculator. Yes, yes, yes? Okay. And that's fine. Or borrow one from a friend or something like that. Maybe you have a sibling, older or younger sibling that's not using theirs or something like that. Or a cousin or something like that, okay? Just get one, okay? Because it's going to be super helpful for you. The sooner you get it, the easier things are going to be for you, okay? I promise. Because there's not going to be a situation where you won't be able to use that graphing calculator in this class. Every question, every test, every quiz, every homework problem, you'll be able to use that graphing calculator. I'm going to show you how to make it life easier for yourself with it. Okay? So we found our points of intersection, right? It's at x equals 3 and -3. You don't really need to give me the y coordinates. That's okay. Okay, but there's our answers. Okay. If you want to here, we can also sketch out the graph of this. I'll do that here real quick too. Okay, if you don't want to sketch this out, please do not feel obligated to do so. I'm going to do it just because, you know, I want you guys to have a picture there if you want one. 1, 2, 3. 1, 2, 3. Okay. If you ever come across something that you're not sure how to graph it, right, I'm going to graph x squared. I'll graph that in, I guess, the blue here. Okay, I'll graph the 9 in red. Okay, if you ever come across something you don't know how to graph, just make a table, right? And we'll get more practice with graphing x squared here in a little bit. Okay, so don't fret too much there. But you know, if you're like, ooh, you don't know much about graphing, we'll get to that. Okay. Okay. So I'll pick some x values here. I'll go from -3 to 3. Okay, like so. And let's see here. So -3 squared will be 9, 4, 1, 0, 1, 4, and 9. Okay. And then let's see here. Well, g of x equal to 9, it's going to all be 9s. Okay, no matter the x, the y value will be 9, right? G of x just equals 9 there. So then g of x will just be this horizontal line here through 9. Okay. And then I'll plot these points here for f of x. Again, how do I get these y values? I just plug that negative 3 in. Negative 3 squared is positive 9. Negative 2 squared is positive 4. Negative 1 squared is positive 1. So plot these points here. Okay, and there again you can see the points of intersection where the two graphs intersect. And it's again at negative 3 and positive 3. So again, don't feel like you need to graph that down though if you have your graphing calculator, that's all you really need. Okay? So that's one way to solve any quadratic equation you come across right there, right? You can always solve this quadratic equation by graphing it, if it has a solution. You can solve it by graphing it, where the two sides intersect. Okay? Another way to solve, oops. Okay, you can also solve these quadratic equations by factoring sometimes too, right? Okay, remember though, to solve by factoring, right, remember from our warm-up here, to solve by factoring, you have to be equal to what number?
0.
0, right, okay? So to make this equal to 0, what do we do to both sides? What should I do to both sides to make this equal to 0?
Was that minus? So you don't have to add?
It's an equal 16.
Oh, I couldn't see
So what do we got to do here to make it equal to 0?
Divide by 16.
We wouldn't, if we
No,
divide by
minus,
16, it'll become 1. Yeah, we want to minus. Subtract 16 on both sides, right? Minus 16, minus 16. Okay, so you get x squared minus 16 equals 0. Okay, and so now we use our AC method. This is another way that we can solve this, right? So AC. So what's our A equal to in this problem?
1.
A 1. Very good. What's our C equal to in this problem?
16.
Negative 16, yeah. Okay, so we two numbers that multiply to negative 16. Okay, but they also need to add to make, what's our middle term here? What's the B? Yeah, add to 0. Exactly. There's no middle term, so it's going to be 0. So what are two numbers that multiply to negative 16 but add to make 0? Numbers that multiply to negative 16 but they add to make 0.
4 and negative 4.
4 and negative 4, exactly right. Okay, so we'll take that, we'll break it up. Plus 4x minus 16 equals 0. Sorry, I'm getting in my own way here. Okay. And again, if I were to simplify this, right, I would go right back to the original problem right there, right? Plus 4 minus 4 would cancel out, and we just have the x squared minus 16. But we do it this way so that I can group that first 2, group the second 2. From this first group, what can I take out?
X.
An x, right? Yeah. What can we take out from this second group?
4.
A negative 4 we'll take out. Yeah, negative 4. Okay. Negative 4x divided by negative 4 is x. Negative 16 divided by negative 4, positive 4. You can see with the same leftovers there. Okay. So x plus 4 equals 0 and x minus 4 equals 0. So x equals negative 4. And add 4 to both sides there, x equals 4. Okay. Again, once you factor it, set each factor equal to 0, right? That's a 0 product property there. X plus 4 equals 0, x minus 4 equals 0. Negative 4 and 4. All right, questions on any of that? Got a few more here I want to show you. Okay. So again, our idea here is we're trying to use square roots. Now I haven't really used square roots here yet, right? I showed you how to solve this equation first by graphing, right? So we graph the left-hand side. We graphed the right-hand side, and we found the point of intersection. That's one strategy you can use, right? We solved by factoring as well. Okay, you can see there's the factoring stuff. And again, we did factoring in the one-up too. Here's where we're actually going to use the square root. Okay, solve x squared equals 9. And here's where we'll actually use the square root. Okay, so here's what we're actually going to do with the notes said we were going to do. Okay. We already solved this one, right? We solved it using the graphing. We could solve this one just like we did number 2 as well. I could subtract 9 over and then factor it. But we're going to solve it by using actual square roots here and stuff. Okay? So, first thing you want to do is isolate the square root, or the square term. Isolate the square term. Okay? Our square term here is already isolated, right? It's by itself. It's x squared, right? And it's by itself. There's nothing else with the x squared on this side that I can get rid of. Okay? So that's what we've got. We got x squared equals 9. Check. We're there. Okay? Or I'll put the check over here. We check. It is isolated. Okay? Next step. We take the square root of both sides. Okay? The square root, remember, it looks like this. Right? A little symbol like this. Okay. If you want to, you could put a 2 in there as well. You don't have to, though. If there's no number written, we assume it's a 2, right? But we'll be using like a 3 and stuff like that for other problems. We'll do like symbols and things like that for other roots. What is the square root of x squared? What does that simplify to be? X, yeah. What's the square root of 9? 3. But since we're in an equation setting, we're going to say plus or minus 3. Positive 3 and negative 3. Okay? So 2 solutions there, right? If you don't like writing plus or minus, if that's weird to you, feel free to break those up into 2 different solutions. X equals 3 or x equals negative 3. That's another way you could write it too. Okay? Because plus or minus to me was always like a weird concept. How do you plus and minus something? You know, kind of thing. So I just break it up into 2 different things. Questions on any of that so far? All right. Two more examples here for you, and then we'll have you guys try some on your own. Okay. We have 2x squared minus 16 equals 0. Are we ready to take the square root right now, the way this equation is written? Should we take the square root as our first step?
We're going to isolate it.
Right, got to get the x squared by itself, right? So I'm going to rewrite that here. Isolate x squared. Okay, isolate x squared. So that means we've got to get the x squared by itself. Bobby, what's with the x squared on this side of the equation over here?
The 2.
Okay, the 2 and what else?
And then minus 16.
Yeah, so which one are we going to get rid of first?
Minus 16.
Yeah, and we'll get rid of that by?
Adding 16.
Yes, so add 16 both sides there. Okay, 2x squared still remains over here, and 0 plus 16 is 16.
Then divide both sides by 2.
Divide both sides by 2. Very good. Now we have the x squared isolated, right? X squared is equal to 8. Okay, thank you, Bobby. So then at this point, the x squared is isolated. We got it by itself. Okay, now what should we do to both sides? How do you get rid of a square? Square root, right? Then square root both sides. So square root, square root. Okay, we have x equals and now what's the square root of 8?
Doesn't have.
It's not a perfect square. You're right, it doesn't have a perfect
8 squared.
number. So we can put plus or minus here, the square root of 8, okay? But we're gonna simplify this a little bit, okay? Because we can actually kind of like work 8 a little bit to make it a little more simplified, okay? So plus or minus root 8 is good, but we want to aim for better than good, okay? So we're gonna simplify this root 8, okay? And the way we're gonna do that is we're going to think, okay, are there any perfect squares that divide 8?
4.
So 4. Okay, 8 is 4 times 2. So I'm going to rewrite this square root of 8 as the square root of 4 times the square root of 2. Okay, you see I'm making the same.
The square root of 4 is 2.
Exactly. So we take that square root of 8 and we break it up using a perfect square, right? Root 8 is divisible by 4. It's 4 and 2. Okay? And then what is the square root of 4? It's 2, like Bobby said. So plus or minus 2, right? So I take the square root of 4 and I get 2. And I still have this square root of 2 that I can't simplify.
Do you have to put the multiplication symbol in front of it?
No, you don't have
You
to.
could just do
If you
2
do
root 2.
If you do 2 root 2, that's fine. Yep. Can I divide any more perfect squares?
What?
Go ahead. Yeah. Can we divide any perfect squares out of this 2 right here?
No.
No. So this is as simple as we can get. And that's our final answer. Positive 2 root 2, negative 2 root 2. Okay? All right, got one more for us here. And then I'll get you guys a problem.
The square root of 1 would count as 1?
Yes,
Literally just
1. Yes, but if we every number goes divisible by 1.
You could just take that, yeah.
But and that wouldn't change the value of it, right? It still kind of stays the same. Okay, but that's right, Bobby. That's true. You can always take a 1 out. It just isn't always. It's not really helpful because it doesn't reduce the number at all. It stays the same size. Okay. All right, Liana. How about this next one, Liana? What should we do here to solve this equation? First step.
I have no idea.
So we have an x squared here, right? Okay, we want to get that x squared by itself. Remember here, that's one of our big things. We want to isolate the x squared. So what's with the x squared there, Liana, that we need to get rid of?
9.
9, yeah. How do you get rid of a positive 9?
Subtract.
Yeah, we're going to subtract 9 from both sides. You got it. Exactly right. So we'll have a negative 5x squared left here, and then negative 9 here. And then what?
I don't know.
Well, what's with the x squared still?
5.
Okay, and it's negative 5. And when it's written next to the x squared, what operation does that mean? When you have a number written next to a variable like that, does that mean add, subtract, multiply, or divide?
Divide.
Well, we're going to divide, right? I mean, it means multiply, but we will divide there, both sides by negative 5, right? So we get x squared equals a negative divided by negative, positive now 9/5. And I'm going to leave it as this fraction, okay? I would discourage you. I'm going to discourage you from, converting things to decimals and stuff like that with your calculators. I think it's going to be more helpful for you to leave it as this improper fraction. Okay. All right. So Liana did a great job there, isolating the x squared. Okay. Let's go to Jacob K. Jacob K. At this point, now what should we do to both sides? Square root. You got it. Square root. Okay. Square rooting a fraction. Well, that's easy. It's going to be x. And then, we have the square root of 9/5. When you square root a fraction, okay, it's the same thing as taking the... Oh, I should have plus or minus there, too. It's the same thing as doing the square root of the numerator divided by the square root of the denominator. Okay, so you can break up that square root over division. Okay. So let's see here. How is that helpful? Well, Phoenix, what's the square root of 9? Can we square root 9? Yeah, it's 3. Okay. Phoenix, can we square root 5 though? No. Root 5 is not a perfect square. So we're going to leave it like that. Are there any perfect squares we can divide 5 by? No. Okay. So this is kind of it. This is the best we can do. However, we have to do something called rationalizing the denominator. Okay, rationalize the denominator. We can't leave a square root in the denominator. So how do we fix it? It's really easy, actually. We multiply the top and bottom of the fraction by what's in the square root there. So we're going to multiply the top and bottom by a root 5 and a root 5. Okay? Because what is root 5 over root 5 really equal to? It's 1, right? So am I changing the value of this?
Yeah.
When I multiply by 1, it doesn't change the value, but it changes how it looks. So it's going to be plus or minus still 3 root 5 in the numerator over, and then root 5 times root 5 will be the square root of, well, what's 5 times 5?
25.
Yeah, it'll be the square root of 25. And what is the square root of 25?
5.
Yeah. Okay. Can I simplify this 5 and this 5? Can I cancel these two out? No, why not? They're not the same. Yeah, why aren't they the same? They're both a 5, but what's the difference between the two? Yeah, one's the square root of 5, one's just 5. So these are not the same. We can't cancel those out. So we're just going to have to stop right there. There we go. Okay. All right. Let me give you guys 2 to try here. Okay, so here's finally something for y'all to try. Okay, so solve by taking square root. Okay, first. Okay, there's one for you to do. X squared minus 24 equals 0. And here's another one for you to do. Okay. So give those 2 a try. Sure. Give those 2 a try. Feel free to go back and look at your other examples that we got, in our notes and stuff like that. Use these to help guide you. Remember the big picture of things. Isolate the x squared, get the x squared by itself, then square root both sides, and then simplify. Okay, so isolate the x squared, take the square root of both sides, simplify. Okay, 1, 2, 3. You go write those up here too. So there are your steps right there to help you. Let's give it a try. Give it a try. See what you guys can do. See if I can square root. See what you can do there. I'll do the video with it. Try the problem first. Okay. See what you guys can do there. Doing all right? Stuck.
I was trying to stay away from there. I had a really hard time.
Okay, well, again, I gave the directions right there. Just follow those steps. Do you feel like you can isolate the x squared term there in that first problem? Like, what would you need to do to get the x squared by itself?
Probably. It's just a matter of trying.
Okay. Well, yeah, start writing it out. If you need help, Rohan's right there too. If I'm over here somewhere, okay. Just write it out. See what you do. Okay. Yeah, good job, Luke. 100%. Yeah, good job. You want to speak them? All right. Yes, Lindsay, question. Yeah, looking good. So now this one, you don't need to rationalize because when you square root, the 2, the square root of 4 becomes just a 2, so there's no square root in the denominator. So you can actually leave it what you had right there. The square root of the denominator, exactly. You don't want to do it. So you can say plus or minus term 2 and you're good. So good job, though. Good thinking, though. I'm glad you're looking out for that. Yeah, you got this stuff okay, honey? Okay, plus or minus. And plus or minus there too, and then you're good. Yeah. Michael's going to go on that when he comes back. Is that okay?
Yeah, that's fine.
All right, unless it's an emergency, then you can go. Michael, you okay here? Okay, if you need help, let me know. Things you do all right? Looking good. See if you can simplify that root 24 at all. Think about any perfect squares you can divide 24 by. Okay. All right, Leanna, you got any more further here? Okay, yeah, that's right. Good job. Okay, so you put a plus or minus in front of that. Okay, because it's like when we square root both sides, you see how I did right here. Square root of both sides. I have a plus or minus in front of the answer there. You can't see it? Oops. Thought I had frozen. So here where I had x squared equals 9/5, right? I square root of both sides, and I put a little plus or minus in front of my answer there, okay? Because you want to have both a positive version and a negative version of your answer. Okay, now, we also want to see if we can simplify that 24. Can you think of any perfect squares that divide 24 evenly? Do you know what I mean when I say a perfect square? Okay. So 6 does divide 24 evenly, but it's not a perfect square. Okay, so thanks for saying that. So a perfect square is an example of a perfect square would be like 4. Why is 4 a perfect square? Because it is equal to 2 times 2. Makes sense? 9 is a perfect square because it's 3 times 3. 16 is a perfect square, 4 times 4, so on and so forth. You get it now?
Yeah.
So what can we divide 24 by that's a perfect square? For example, can you divide 24 by 4?
Yes.
Bobby says yes. Do you agree, though? Yeah, okay. So, Avery's next in line. So once Avery, once Avery gets to go, then yeah. All right. So, unless it's an emergency, Luke, and then you can go. Okay. So, you want to break up that root 24. All right, this is what you have, plus or minus. And so that's equal to, right? 4 times 6 would be the 24. We break it up because what is the square root of 4? 2. And then there's your answer. We can't divide 6 by any other perfect squares, so we know we're done. 2 root 6 is our answer. Does that make sense now? Yeah, you're welcome. And then you'll simplify the other one in a similar way. Okay, let's go ahead and go over this, though, because I want to make sure you guys have time to work on your homework and stuff, too. All right. Let's take a look here, okay, at number 1. And let's go to Hannah. Hannah, number 1. What do we do to both sides here to solve this equation?
I add 24.
That is exactly what you should do. Okay, x squared is 24, and then?
And then you take the square root.
Very good. Square root both sides. So x equals plus or minus the square root of 24. Did you get any further than that?
No, I did, but isn't there not a perfect?
So 24 is not a perfect square,
Yeah.
but we can divide it by a perfect square. So so a perfect square, right, is like, so 4 is a perfect square because it's 2 times 2, 9 is a perfect square because it's 3 times 3, so on and so forth, right? 16 is 4 times 4, so you can use 16, stuff like that, okay? 24, it divides by 4, which is a perfect square.
Okay.
So it would be plus or minus square root of 4 times the square root of 6. Okay? And what is the square root of 4? So we get plus or minus 2 root 6 there. Okay? And we know we can stop because the square root of 6, there's no, like, we can't divide 6 by 4 or anything like that. So we know we're done there. And that's the final answer. If you got to here, that's good still. I mean, don't sweat if you only got to here. But I do want you to be able to simplify. So make sure you can, you get that figured out too if you're having trouble with that. Okay? All right, last but not least, number 2. Thank you, Hannah. Let's go to Chris. Chris, what'd you do here for your first step?
I subtracted 13.
Subtract 13 on both sides. Very good. We want to get that x squared by itself. We have negative 4x squared equals negative 13. And then what?
Divided it by negative 4.
Divide by negative 4 on both sides. You got it. So you get x squared equals negative 13 by negative 4 is going to be a positive 13 fourths. All right. I'm not going to simplify that just yet. I'm not going to change it to a decimal. I want to leave it as a fraction because it's easier to simplify when you have it as a fraction. All right. Go ahead, Chris. What's next?
Take the square root.
Square root. You get x equals plus or minus root 13 over 4. But remember here, folks, when you square root a division like that, you can make it root 13 over root 4, like that. Right? You can break up the square root. And that's helpful here because what is the square root of 4? 2, right? So our denominator simplifies to just 2. Can I simplify 13 at all? Does 13 divide by any perfect squares? No. Okay. Do I need to rationalize here, like I did in this last example? Do I need to rationalize here? No. Why not? There's no square root in the denominator, right? So up here, right, where Mr. Whitmire simplified and we had 3 over root 5, I multiplied by root 5 over root 5 to get rid of the square root in the denominator. Here, when we did the square root, it just simplified to 2. We didn't need to do any more work. We're done here. This is it. This is all we have to do. Square root 13 over 2. Okay? Our 2 answers there. All right, questions on any of that?
Like, instead of just doing the plus and minus in the front, I wrote it out I wrote 2 separate answers, like x equals and x equals, and is that like still right?
That's fine, absolutely, yeah. Mm-hmm. I just didn't do it because I was lazy, okay? But you're welcome to write out 2 different answers. Questions on anything? Okay, so as promised, I'm going to give you guys your homework assignment, but I'm also going to pass out your tests so you guys can see how you did.